Okay, pre-calc, we are still in 8.3, just continuing on. And remember, your first step is to get the exponent by itself. So what you'll see me do is subtract 1 over. So we're at 9, and then I'm going to divide both sides by 3. So 9 divided by 3. We're left with e to the x minus 1 is equal to 3. And then from here, I would follow our pattern of undoing the e by taking the natural log of both sides. And then you're just left with x minus 1 equals natural log of 3. So our final answer for x would be the natural log of 3 and then add 1 to it. So if this were a multiple choice on a non-calculator test, this would probably be the answer. Otherwise, you would need a graphing calculator to type in natural log of 3 and then add 1 to that value. So 2.099. And don't forget that you can check your answer, by plugging in. Now, be careful when you plug in 3e. If you hit the answer key, you'll actually get a good answer. So second negative sign copies that value, minus 1, and then just over 1, and plus 1. Some calculators you actually have to put in parentheses there. But what you see is you can check your work that you get the correct answer of 10. So if I'm explaining this too fast, just write down your question, bring it to class, things like that. Because there's two different ways you could do this next problem, which is why I wanted to start over in a new video here, is you can actually get them to be the same base right away. Like you can change 8 to be 2 to the third power, and that exponent is still there. And remember, a power to a power, you multiply those exponents. So I hope you agree that 2 cubed is 8. And then as I multiply those exponents, I get 3x minus 3 is equal to 3x plus 4. Well, as I subtract 3x over, we kind of have a false statement. Negative 3 equal to 4. That is impossible. There is no solution here. So what that means is that neither of these will intersect each other. So if you were to use a graphing calculator, if you go back to y equals and you type in 8 to the, I already forgot what it was, x minus 1 power, and then 2 to the 3x plus 4 power, I think you'll notice that they never cross each other. I mean, it might seem like they do over here, but they do not. And if I use Desmos, we can zoom in and actually see it pretty easily that they won't cross each other. Yeah, I'm kind of hesitant to show you another way, but this way that I'm showing you here is different than the other ones where I've been telling you to take the log of both sides. Now, as we look at the next one, make sure that you recognize that this is just a quadratic type problem. For instance, I'll use y, like y squared minus 4y minus 5. Okay? If you can factor that problem, you should be able to factor this. And what am I talking about is, in my example, y is equal to e to the x. And the reason why I bring that to your attention is if y is e to the x there, pretty clear that that's the same. So if y is e to the x, then what's y squared equal to? Well, it's equal to e to the x squared. And again, a power to a power, you multiply those exponents. Well, x times 2 is equal to 2x. So this is the same thing. So if I went back to this statement and you said, oh, if I factored that, it would be y minus 5, y plus 1. I would say, good, now factor this. And the only thing is, instead of having y's, we have e to the x's. So this is the same thing as e to the x minus 5, e to the x plus 1. And just like when we did the zero product property before, we can say that e to the x equals 5 or e to the x equals negative 1. And now we can solve for x by taking the natural log. Now, I know in an earlier video I mentioned this, that we cannot natural log a negative number, but I did not really explain why. Now is a perfect time to explain why we cannot log a negative. And it goes back to exponential functions always give us positive answers. Well, how can I undo a problem? And you undo the problem with a natural log or log. Well, if this answer cannot be negative, well, then I can't undo that problem with a negative. So there's two rules here. There's two ways of thinking about it. Either remember that you cannot log negatives. So that's bad. You cannot log negatives. Or you can think of it this way, is any exponential will give me a positive answer. So if I can only get a positive answer, there's no possible value for x to give me -1. All right. So as I look at the next problem, okay, I could have done this problem the same way, but the bases were okay. The bases were the same. So now, as I look at this, it's impossible to get both the bases to be the same. So you have the choice. Do you want to use, I guess, which log do you want to use? Most teachers like using natural log. I shouldn't say most teachers, but the teachers I've worked with have chosen to use natural log instead of any other log. But you can use any log. And the reason why is now we can take these exponents and we can move them in front. Now notice that I'm putting these exponents in parentheses because what we really have is we need to distribute natural log of 2 to both the x and natural log of 2 to that 2 is equal to, again, x natural log of 5 minus 3 natural log of 5. Because it's the quantity. So what I usually do, and my way does work, so you can follow my method or you can find a different one that's also correct, is I get the x's on the same side and all of the other pieces on the other side. So that way I can greatest common factor out an x. Whoops, did not want a parenthesis yet. And so now it's just a multiplication problem. Well, how do we solve a multiplication problem? All of this is still the same over here, by the way. Well, we solve a multiplication problem through division. So what I can do is I can divide this natural log of 2 minus natural log of 5 over here. And this would be a perfect answer, but I think you guys know me. It would be good if you gave me an approximate answer as well. So on my home screen, maybe make a fraction where I can type that in. Just make sure you hit the negative key when you need a negative number. Natural log of 5 minus, oops, need to close those parentheses. To natural log of 2 over natural log of 2, close that parenthesis, minus natural log of 5. 6.782. And as I mentioned before, you can check that your answer is correct by typing that in to the original problem. If I were to type in 2 to the answer, so second, a negative sign, plus 2, so that decimal, and then plug in the other one, 5 to the, oh man, I'm going to have to grab that equation. What was it, minus 3? Yep. And my decimal's off just a little bit because this one I rounded, but I think you'd agree that that's close enough to being perfect. So here's another very wordy thing, but it's really the same thing of getting you to practice. Okay, well, if we're adding, then we can multiply, x plus 2 is equal to natural log of 8. And really what we're doing on both sides is we're taking e to both sides to cancel them out. But then we have this, I think this is the same problem we did on an earlier unit. Instead of setting them equal, I would subtract the 8 over to solve. And then we can factor. Again, I'm pretty sure this is the same problem. So I'll quickly say that the answers would be -4 and +2. But remember, we can only log positives. So -4 does not work. Just like in the first video, I'm sharing with you the answer key. So if you want to hit pause and write down anything that you might need as clues to help you. Really the same directions as before, except we'll be giving logs instead of the other. And don't forget that you can use a graphing calculator and to make sure that you check your work, because we can only log positive numbers. I don't like how you phrase that either. So again, hit pause, write down what you need to. These are your notes. And I can scroll up if anybody, well, there you have it. So remember your law of logs as well. For instance, as I look at this next one, we have a subtraction, so make sure you divide your arguments is equal to 3. I would change this to exponential form. Technically what I'm doing is taking 2 to each side. I guess you can think of it that way. So 2 cubed is 8. And what I would also do is multiply that term over. I don't know if I should change colors to really show is equal to x plus 2. So as I'm looking at this problem now, I can solve it by distributing 8 in there. So I would probably subtract 1x to the right side and add 8 to the left. So when I divide, I'll get x equals 10/7. And is this an acceptable answer? Let's see, 10/7 plus 2 is positive. 10/7 minus 1 is positive. So that's a good answer. This next one, if you notice, we have logs on both sides. Pretty straightforward, though, that you can, take e to both sides, but they're going to be equal. So x plus 3 equals 2. So if I subtract 3 over, I get x equals -1. Now, this is an okay answer. Even though it's negative, when I plug in a negative right here, -1 plus 3 gives me a positive number. So I do get a positive, and we can natural log that. So that's fine. As I look at the next one, the log is not isolated. You have to add that 3 over. So we're looking at log base 3 of 2x minus 1 is equal to 4. So technically what we're doing is taking 3 to the 4th power to undo the log. Well, 3 to the 4th power, 3, 9, 27 is 81 is equal to 2x minus 1. So add 1 over and divide by 2, and x would give me 41. Don't forget to double check that your answer makes sense. If I plugged in 41 here and double it and subtract 1, I get a positive. So we are good with that answer. Just a few more. Think about our law of logs that we can multiply, and make sure you distribute as well. I think I've shown you enough to this point where you know to distribute. Now, I would actually just leave this as log of 10. I do realize that log of 10 is exactly 1, but what you want to do is leave this alone, because when you take 10 to both sides, we want to have it equal 10. So because it's a quadratic now, I want to set it equal to 0, so I would subtract that 10 over. And factors of 10 that add to be 3, 5, and -2, so that means x must be -5 and +2. But the only one that works is the +1. All right, I've run out of time, and I don't want to make a third video, so here's the last couple. Hit pause before this video ends, and you should be ready for the homework.